The most commonly used intermediate events are none, message, and timer. We will study these in depth later on. Now we have seen the events, we are going to look at gateways. As we have seen previously, gateways are elements used to control divergence and convergence of the flow. That is, gateways allow us to divide the process flow into various routes, that can be alternatives or not, and allow us to join various routes into one. They are represented by a diamond. Depending on the place in the flow where the gateways are located, they act as an element of divergence or an element of convergence. If there are various outgoing routes from the gateway, it is used as an element of divergence or decision. If there are various sequence flows arriving at the gateway and only one outgoing sequence flow, then the gateway is being used as an element of convergence or of synchronization. There are also different types of gateways. The icon on the inside of the diamond indicates the behavior of the gateway. The types of gateways are exclusive gateways based on data, exclusive gateways based on events, parallel gateways, inclusive gateways, and complex gateways. The most commonly used are exclusive gateways based on data, parallel gateways, and inclusive gateways. The exclusive gateway, as an element of decision, indicates that only one route can be taken from various available. There are two types of exclusive gateway, based on data and based on events. As an element of convergence, it enables the joining of alternative routes into only one. The parallel gateway, used as an element of divergence, allows you to generate various routes concurrently or in parallel. The parallel gateway, used as an element of convergence, allows you to join various routes that are executed in parallel into just one. The inclusive gateway, as an element of decision, indicates that one or more routes can be activated from various available. As with an element of convergence, it indicates that the various outgoing routes of an inclusive gateway, used as an element of divergence, can be synchronized into just one. We are now going to summarize what we have seen up to now. BPMN establishes three basic figures for the diagramming of processes: activities, events, and gateways. These three figures are grouped within the category called flow objects. Each of these figures has different types that enable us to represent more complex business situations. Within activities, we find processes themselves that are represented by pools, atomic activities called tasks, and non-atomic activities or complex that are known as subprocesses. Within events, we find start events, intermediate events, and end events. Gateways are the elements used to control the divergence and convergence of the flow, i.e., they are elements that are used to represent decisions or points where the flow can open into various routes, or can also represent synchronization points, i.e., where various routes are joined into only one. We have also seen that there are different types of gateways, depending on the type of decision or synchronization that is required. In conclusion, flow objects are graphic elements that allow us to define the behavior of a process. The second category that we find in a business process diagram is connection objects. Within this category are the sequence lines that enable us to connect flow objects between themselves, i.e., activities, events, and gateways. Message lines that allow us to represent the interaction between various processes, and associations that allow us to include more information within the flow. The third category are swim lanes or canals, that are the elements used to differentiate the participants involved within the process. In this category, we have pools that act like containers of a process, and lanes that are subdivisions of pools that represent roles, functional areas, etc. Finally, we have artifacts that are used to provide more information about the process. Within this category, we find data objects, notations, and groups. We are now going to see how to change the types of figures within the Bizaji Process Modeler. The Bizaji Process Modeler allows us to easily add information to the process, making it more complete without making drastic changes. In this way, starting from the basic, you can gradually add to it to make the process more complete. As we have seen during this presentation, all the flow objects present a sub-classification or some subtypes. That is, the activities as well as the events and gateways have some subtypes depending on their behavior. To change the type of whatever object, right-click over it and select the type of object you need to use. In this process, we can say that the process starts when the purchase application is received, i.e., that the type of start event will be a message type start event. Later, we can say that the Verify Purchase Application activity is a user activity. That is, a user activity with the help of a system or software. Afterwards, we can say that the quotation and invoice payment activities are sub-processes, i.e., they are complex activities. To transform an activity into a sub-process, right-click over the activity and select Transform Into and select Sub-Process. Quotation, therefore, will be an embedded sub-process. That is to say that it is a process that depends totally on the parent process. Invoice payment will be a reusable sub-process. Right-click over Invoice Payment and select as sub-process type Reusable. We can also say that the Receive Invoice and Receive Merchandise can be performed in parallel. For this reason, the gateway will be of parallel type. Good. Additionally, when we have sub-processes, we can edit them directly from this diagram. When the sub-process is embedded, when we right-click Edit Sub-Process, the modeler opens a page where we can diagram directly the process. Therefore, we will quickly diagram the quotation process. The first activity is to select the supplier. Then we are going to request the quotation. Once the quotation has been requested, we are going to receive it. Note that one of these events will be send and the other reception. For this reason, this will be the event that sends the message, and this will be the one to receive. Good. Now we have our process returning to the parent process. And the invoice payment process, as a reusable sub-process, can be done in another diagram. Remember that a reusable sub-process can be used from various processes, and for this reason can contain pools and lanes, which is different from an embedded process, which can contain neither pools nor lanes. Once I have the process diagram, to associate it therefore, I should go to the sub-process figure, right-click on Properties, and select the diagram in the diagram field that in this case will be diagram 2, and the process in the process field that in this case will be invoice payment. Once I have done this, the process now is associated as a sub-process. For this reason, I can now edit directly from the sub-process figure. To do this, right-click over the sub-process and select the Edit Sub-Process option. Note that this option is only available after associating the process to the reusable sub-process figure. Good. Now we are going to practice what we have learnt by completing the following exercises. Remember that the Process Modeler is completely free and can be downloaded from our webpage, www.bizagi.com.